I wanted to do a video with some extra examples of trig problems just to make sure you've really got this down and some of the different scenarios that can happen. So I've got 3 examples here and I've got a 4th one written down on paper that I want to do in a second. All right, before we start, make sure your calculator is in degree mode, okay? If you take the sine of 30 degrees on your calculator, that should be 0.5. If you're not getting that, you're not in degree mode and you need to get your calculator changed to degrees. All right, so how's this going to work? Well, remember, each time you take your angle measure and you decide which one of the trig rules you're going to use, the SOHCAHTOA rule. So opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. So in this particular case here, my 50-degree angle. Now, you could switch. This is a 40. If you wanted to use the 40 instead, that's totally fine. But pick one of your 2 acute angles and stay with it, okay? I'm going to use this side, though. So this angle is 50. The side across from it would be the opposite. And the leg that's next to it would be the adjacent, okay? So if you look at your rules here, tangent involves the opposite side and the adjacent side. And so it's going to be a tangent equation. Remember, you take the sine, cosine, or tangent of the angle measure. So you're telling your calculator, hey, I've got a right angle with a 50-degree angle, and then you're going to fill in the fraction. It's the opposite side over the hypotenuse. So opposite is x, the hypotenuse is 5, and should be able to run those numbers. So you type in the tangent of 50 to your calculator, and you get about 1.1918. Anyway, I'm just going to leave it like this. I'm going to leave the number in my calculator. And that's equal to x over 5, okay? I don't want x to be divided by 5, so I'll do dividing by 5 by multiplying by 5. And I'm going to take that decimal that I currently have in my calculator, multiply by 5, and we're going to find out that x is approximately 5.96. Again, you're probably going to be asked around to 2 or 3 decimal places, so do watch the directions there. By the way, you should kind of check and see if your answer makes sense. This is a 55-degree angle. This would be a 35. Remember that the shorter side is opposite the smaller angle, and a longer side is opposite the longer angle. And so, oh, that's not the problem I'm supposed to be doing, is it? It's this one over here. Anyway, but remember that this is about 5.96. That's a 50, that's a 40. So a shorter side should be across from a shorter angle, a longer side should be across from a longer angle. That works. Our answers make sense, so I'm pretty confident that I'm correct on that one. We'll get to number 3 in a minute. Let's take a look at number 2. Number 2 here, we've got a 35, we've got an opposite side, we've got a hypotenuse, okay? So sine compares the opposite and the hypotenuse. So you take the sine of the angle that you use to label everything, that's sine of 35, it's going to be the opposite over the hypotenuse, 10 over y, okay? You can run sine of 35 on your calculator. It's about 0.573. And again, I'm going to leave it in there. It's equal to 10 over y. Be careful. We now have a variable in the denominator. I don't want the value of 1 over y. I want the value of y, which is y over 1. Okay? So you need to get the variable out of the denominator. Okay? 10 is being divided by y. I don't want y in the bottom, so I'm going to multiply both sides by y. It's going to give me a y over here, and it's going to leave me just with a 10 on this side. Okay? So y is being multiplied by that decimal that's coming from the sine of 35. Now I need to divide by that sine of 35 decimal. Okay? 10 divided by the sine of 35 is going to give me my final answer. And in this case, and by the way, you don't have to type that decimal in. You can either use the answer button on your calculator, which is second, and I think it's down here by that little negative symbol, and it'll bring back your previous answer. Or you could just say 10 divided by the sine of 35, because you know that's where that decimal came from. And y is going to be about 17.434. And again, look at this problem. 35-degree angle is pretty small, so we would expect the hypotenuse to be pretty long in comparison to that side. And so yeah, I think 17.434 makes sense. By the way, other ways to do this problem that'll also work, if you were at this point in the problem, if you don't like trying to decide, hey, is my variable in the bottom of the fraction or is it in the top, remember you can always just make it into a proportion. And you can cross multiply here, that'll give you 0.73y is equal to 10. And you could just solve it, you'll get the same equation. Great way to do this if you prefer proportions. By the way, the other way you can get around this, you can actually use the other angle, okay? If this is a 35, this angle here is going to be a 55, okay? Um, and you could have done, notice here in this particular case, it was a y here. You've got the adjacent, let's see, you've got the adjacent and the hypotenuse. So you could have done a cosine of 55 is equal to 10 over y, and you could have solved it that way, and you're still going to end up getting the same answer. It's just going to kind of move things around a little bit here. Anyway, different ways that you can approach this, but you will get answers that work out the same. Let's look at number 3, and then I've got one other application here. All right, we've got an opposite side and a hypotenuse. Okay, that is going to be a sine of 35 is equal to the opposite over the hypotenuse. It's 4 over z. Okay, we can take the sine of 35 here. Sine of 35 is going to be about 0.573. That's equal to 4 over z. Okay, I don't want the z in the bottom of the fraction, so I'm going to multiply both sides by z. And that's going to give me about 0.573 z is equal to 4. I can divide both sides by 0.573. And again, try to keep the whole decimal. I have the whole decimal in my calculator here, so I'm going to take 4 divided by that whole decimal that I'm getting from the sine of 35. And we're going to get an answer of about 6.97 as our value for z there. And that should make sense because it's the hypotenuse, it's the longest side, it's a little bit longer than the 4. Makes sense, all right? Now, one of the other things you're going to see in these problems, I told you trig is really, really powerful. Basically, anytime that you have an angle measure or you can get an angle measure, you can use trig to try to solve. So for example, let's say I had an isosceles triangle and it had two 20-degree base angles, and they told me that the base of this triangle had a length of 10, and they want me to find the area. Okay, we know the area of a triangle is half the base times the height. Okay, and I already have the base, so we just need to find the height. The height, of course, is an altitude. It would go right here, and we know from earlier in the year that by hypotenuse leg, we get two congruent triangles here. That means that this length is going to be 5, and that length is going to be 5. So very much like in the previous right triangle sections, you were trying to create right triangles that you could use the Pythagorean theorem, or 30, 60, 90 triangles, or Pythagorean triples. Same kind of thing here. You can make a right triangle. We need to find the height. We can call that h, and we can just look at one of those triangles. So we've got a side length here of 5, we've got a 20-degree angle, and a height of h, and you can decide which rule to use. We've got the opposite side, we've got the adjacent, so that's the tangent of 20 equals h over 5. And by the way, you don't have to put the decimal into your calculator. You could just write an expression. You could say, hey, h is being divided by 5. I'm going to multiply by 5, and it tells me that the height is just going to be 5 times the tangent of 20, or 5 times the decimal for the tangent of 20 if you want to write it that way. But it will save you a little bit of time. And so h is going to be approximately 1.819, and we're going to keep that in the calculator. And the area of this final big triangle here, which is going to be a very short triangle, okay, the height's a little bit less than 2. Area is going to be half the base of 10 times the height of about 1.819. And again, I'm going to keep that 1.819 in my calculator. I'm going to multiply it by 1/2, and I'm going to multiply it by 10, and we find out that the area of the triangle is approximately 9.099 square units, okay? So keep in mind, you can drop altitudes and create right triangles, and if you have angle measures, now you're not relying on it being a 60-degree angle or a 45 or a 30. You can find sides of any right triangles with any angle measures, and that's really, really powerful, as we're going to continue to see in future sections. So I hope these examples help, and obviously if you have any questions, let me know.